everybody, I'm Alexei Krabarov. I'm the organizer of Bay Area AI Meetup. And here we are at Nitro, which is hosting us for a very exciting meetup with Determined AI, which is a new startup. And Evan Sparks, the CEO, is here with us. He's going to give us a talk about this later, which you can also find on Functional TV, where everything goes, functional.tv. But first of all, welcome, Evan.
Thank you. Thank you for
Tell
having
us,
me.
what is Determined AI?
Yeah, so Determined AI, we are building a workbench for machine learning engineers and data scientists who are trying to get their AI-powered features and applications out to market quicker than they could before. So if you've got tons of data, lots of GPUs, deep learning models that you want to encode into your favorite image classification or text-to-speech kind of applications and so on, we help you get those things built faster than you could before.
So I'm a software engineer first and data scientist later, right? So explain it to me. When I see there is a lot of folks who say that they're deploying models to production, and there is this whole industry emerging. Why do we see this phenomenon? Why there is basically a whole class of companies which say will help you productize AI? Why is it just not another kind of software that a lot of people know how to deal with?
Yeah, so I think that what we're seeing is that fundamentally the way we're developing software today is changing as a result of doing data-driven application development. Things change. We've got a lot of uncertainty, we've got statistical randomness, we've got noise, things that you have to deal with that are quite different than writing down a bunch of rules in software. And so we now have the opportunity to make better decisions on the basis of data, build models out that can make more accurate predictions and so on. But it means that almost every stage of the model development process and software development process is going to change. So everything from versioning now comes down to more than just software, it also comes down to the data. Everything around CI/CD and deployment and monitoring also changes because the world changes around us, our models react, and they're more difficult to debug and so on than traditional software. So every stage of that pipeline has to be rethought thanks to these new methods that are powering better applications.
Yes, I think I kind of, as a software engineer, I was preaching this a little bit to the data scientists. So here's my kind of take on this, right? So there is a lot of new folks who came into the industry, and they learn both data science and programming in Python, and they do not go through the traditional career arc of a software engineer when we learn CI/CD and test-driven development and all this kind of stuff, right? So in my mind, that's my kind of first explanation to myself, that this industry arises because there's a whole bunch of folks who are either data scientists without software engineering experience, or they're business folks. So the model is serving business, so business people are watching it, right? And data scientists are working on it, but they don't have the necessarily rigorous experience of deploying and monitoring, rolling back. And so kind of models intersecting software engineers, data scientists, and business people. Is it accurate in your mind? Or?
Yeah, I think there is one way of looking at it where it says, let's take these data scientists who are running wild with their R scripts and their Python scripts and so on, and don't know anything about versioning, and let's instill best practices software engineering kind of techniques on them, and help them understand what it means to put things into production and what uptime really is about, and so on. But I think it's also more nuanced than that. I do think that the process of developing an AI application is quite different than the process of developing a traditional application. So traditional application development, you hit the up arrow, you hit make on GCC, and your artifacts build, and hopefully your tests run too, and you get all green lights, and you're like, okay, I'm ready to go. Here, you hit the up arrow, you hit go, and you wait for 48 hours for your model to converge all the way, and you don't know if it's actually going to work. It's harder to think about what success is and what failure is. And so I think that in part because of that, you've got a lot more tooling that needs to be developed to make the process of developing these applications much more pleasant.
So tell me a little bit, if you know kind of what is your differentiating point, right? I know new companies in this space, they come up regularly. So what is your key strength, and what is your core competence which makes you think you're going to succeed and kind of win in this space?
Yeah, so honestly, the team is a huge piece of this. So we've got a bunch of people from PhDs from places like Berkeley, Chicago, NYU, ex-Googlers, people who've been at places like Pinterest and so on. So really strong technical engineering team, experts in distributed systems. So my co-founder Neil Conway worked on Mesosphere, worked on Apache Mesos. I myself worked on Apache Spark, MLlib, so on, as well as my co-founder Amit Talwalkar. Amit is a professor in the machine learning division at Carnegie Mellon, so we've got a really strong core of people who both know the distributed systems side of things as well as the scalable machine learning methods. So that's a big chunk of it. From a technology perspective, what we've done is take a bunch of the research that we've been doing over the last, call it five plus years, around scalable methods for ML, and think hard about how do we commercialize these and how do we scale them up to the new world of deep learning. And so we have some proprietary algorithms around hyperparameter optimization. I'll be telling you about sort of the open components of that later tonight. We have some really sophisticated techniques around cost modeling for distributed training and deployment. And so all of that kind of adds up to an end-to-end experience, we think, and that hopefully our customers think results in dramatically faster times to build and ship applications, unlike you've ever seen before.
Nice. I mean, I'm really excited that you mentioned the distributed system component, right? Because often in kind of traditional AI talks, we see a graph, we see in a notebook, right? We don't see the distributed systems behind this, and I'm really excited that that comes to the fore, right? Because in real production setting, you need this expertise. Yeah,
it's really hard. I mean, if you're talking about waiting days or weeks for models to converge, you are starting to think about. One of the natural things that you think about is how do I throw more GPUs at this than just the one at a time? How do I do that in an efficient way, a communication efficient way? How do I get scalability that I wouldn't get otherwise from sort of the off-the-shelf tools? How do I do that in a very principled way? How do I make it fault tolerant? How do I make sure it's versioned and so on? And that's where sort of the systems expertise starts to come in. And I think that's a really important component of the experience.
Yes. No, this is great. And so I know that AMPLab actually makes the same kind of connection, right? But maybe for our viewers who did not read up on that much, you can tell us, what makes AMPLab special? Why, things like Spark came out of it?
Yeah, so the AMPLab was really this terrific place at a point in time where you started to see industrially this trend where data sets were getting bigger and bigger. It had never been nearly as cheap or easy to store and process a lot of data. But then the question was like, all right, we've got all this stuff sitting in HDFS. What do we do with it? And luckily, it turns out that more data is great fuel for machine learning techniques. And so the people who founded the AMPLab, my advisor Mike Franklin, Mike Jordan, who we've worked with in the past, and a bunch of the other faculty there, really saw this issue and said, hey, wouldn't this be a great opportunity for communities that haven't traditionally talked to each other, distributed systems, databases, operating systems folks, and really hardcore, deep theoretical ML folks, put them in a room for 5 years and get them talking to each other. And this is, probably 70 or 80 PhD students, a dozen or more postdocs, a dozen or so faculty members sat there and really started to work through these problems. And, I would say that at the beginning of this period, which is when I kind of joined the AMPLab, things were really just getting off the ground and people were kind of uncomfortable talking to each other. John Ducci's sitting in one seat and Matej Zaharia sitting in another seat, and both professors at Stanford now, but it was like they never would have talked before. And suddenly they got together and more folks like them got together and started thinking about how do we reconcile these two worlds, and I think the net effect was something much greater than either of the two sides would have come up with on their own.
And it stood for algorithms, machines, and people.
Yeah, right? That's right.
So and people was a part of this.
People was absolutely a part of this, and both sort of the people who are thinking about these things and using the systems, and that was important. But also there was this really great flavor of crowdsourcing, and how do we think about how we leverage the ability to collect human-powered data from lots of people at once as part of this. And so there were some really interesting projects around mobile devices, around using crowds for data labeling and so on that started to come out, and it was a great line of research.
So I had this kind of humorous, semi-humorous observation about the structure of all AMPLab startups.
Okay.
So if you go to their, if you go to the talks, at some point they show you a chart of the architecture, which I call the 3-layer AMPLab pie. It basically has 3 layers. At the bottom are all things the middle layer reads from. The middle layer is the startup. It may be Spark, it may be Luxio, or maybe Mesosphere, right? So it sits on top of stuff. So it reads from a bunch of things like HDFS or S3, then there is Spark, and then there is a whole bunch of apps like MLlib or application layer frameworks, which is on top of the pie. So if you look at every AMPLab, startup deck or slide presentation, will be a 3-layer pie. So what is your 3-layer pie?
Yeah, absolutely. So sometimes we call this the lasagna diagram.
Okay.
But yeah, so our 3-layer pie, and you're right, there is one of these things. And I was talking to someone over lunch today, and I said, as computer scientists, we're flagrant. We love inventing layers of abstraction that everybody else should use, and so we're guilty as charged. But our 3-layer pie, we start with the underlayer of course, distributed storage and compute framework. In this case, mostly we're talking about GPUs, but also things like edge devices, that mobile phones and so on that might be deployed at the edge for inference. On top of that sits both the existing application frameworks for deep learning, so TensorFlow, Caffe, Keras, PyTorch, you name it.
So you support all of them?
We tend to be, we try to be as framework agnostic as possible. There are dozens of these frameworks. We can't do every one, but we support all the popular ones that we can.
Okay.
And then alongside that, we have our stuff, and above it, which is a distributed job scheduler, something that we think of as the trial optimizer, a hyperparameter optimization set of techniques, which we call the experiment manager, and then a metadata store that really tracks all of the things you've ever tried about developing your deep learning job over time. And then the front end is really sort of command line interface, set of APIs to integrate with the system, and a user interface to help users kind of understand how are my models doing over time.
Cool. So it's very exciting to know that you guys are supporting multiple frameworks. Right? So that makes it really cool. So do you have any kind of pilots in the works? Can you tell us a little bit how's it going? Yeah,
things are great so far. So the company is still early stage. We were founded late last spring and raised some money over the summer. We spent a bunch of the time kind of building out product and so on, and we've got a few paying pilot customers, people in healthcare, kind of the genomic space as well as IoT. Talking to some folks in autonomous vehicles and financial services as well. So far so good. We've got a few real users kicking the system every day and giving us feedback, and so it's been good to see.
Very cool. So in the last question, where do you want to be in a year? Right, we'll check in with you in a year.
World domination, obviously.
World domination, okay? Milestones.
I think that there's really this opportunity to help shape the landscape of how people develop deep learning applications. And you have these great application frameworks, the TensorFlows, the Keras of the world, that are really good at sort of model training on single GPU. But there is so much more to the application development lifecycle around data collection, around dataset management, cluster resource management, deployment engineering that needs to be figured out, and there isn't good software there for it today. And I hope we can contribute in some small part to that and make the world a better place.
Any way for community to chip in? Any open source kind of entry points? So
far, nothing open source from the company. We've certainly been talking about which bits of this should be things that belong to the community. We haven't announced a formal strategy there yet. Certainly, working on making the application frameworks better is a big way that people can contribute.
Sounds great. Well, wish you good luck and looking forward to your talk.
Great. Thank you very much. Appreciate your time.
Thank you.